So we're going to continue reviewing from integrated 1, and we are going to talk about the difference between a linear function and an exponential function. So we're going to write linear versus exponential on the top. And this is going to be a super quick review about what you learned about linear functions and exponential functions from integrated 1. And this is page 4 from Unit 1. I would say that this is a pretty important topic, so I'm going to go ahead and put it on my table of contents. This is page 4. Linear versus exponential. So I have it on my table of contents. I'm going to go ahead and start. I'm going to do linear on one side, and I'm going to do exponential on the other. So you can see the difference between the two. So I'm going to have linear on this side, and then I'm going to have exponential on this side. Okay. So to start, we're just going to write the standard form of both. The standard form of a linear equation is going to be y equals mx plus b, where m represents what? M represents the slope or the growth. Depending on how you want to say it, it doesn't matter, they're the same thing. And B represents what? B represents the y-intercept or the starting value. Again, doesn't matter, they mean the same thing, it's just what you want to call it. So that's a linear function. We have slope, growth, we have y-intercept or the starting value. For an exponential function, the standard form is y equals a times b to the x. So this one we have that x in the exponent. In the exponential function, a represents what? A represents the y-intercept or the starting value, again, however you want to say it. And B represents what? B represents the multiplier, which you can also call the growth. Just this growth is not constant. That's the difference. The linear growth, it's going to be a constant. It's going to be growing by the same number. In the exponential function, it's going to be multiplying by the same number, which it's still growing or decreasing. So let's graph both of them. Just a quick example of a graph. So a linear function is obviously going to be a line. And it could be increasing, it could be decreasing, it could be going through the y-intercept, it could be going through the origin, it doesn't matter. I'm just going to draw that as a quick example. There's a line. This one happens to be increasing. It doesn't have to be increasing. This one has a y-intercept positive. It doesn't necessarily have to have that. But that's just a little example of a line. And a graph for the exponential. This one is not going to be linear because it's exponential. An exponential graph is a curve, and it looks something like that if it is an increasing function. Now there are some similarities and differences. One similarity is they both do have a y-intercept, and I'm going to label where that is. That's the y-intercept here. That's the y-intercept on the exponential. One difference, though, is you'll notice that this linear function has an x-intercept, and this exponential does not have an x-intercept. Exponential functions, in the way that we learn them, do not have an x-intercept. So I'm going to write that down. No x-intercept. They have something else. They have a line right here that will never get touched, and that is called an asymptote. So a linear function does not have an asymptote, but exponential functions do. That's one main difference. You'll notice that in the linear function it goes up at a constant rate. This one goes up very fast, not at a constant rate. That's the difference. So I want to show you a table for each. So for example, a linear function we could have 0, 1, 2, 3, 5, 7. You'll notice, given that table, this is increasing by 2 every time. It's going up by the same number every time. That's a linear function. It's adding by 2 every time or subtracting by a number every time. It's going up by the same number every time. In an exponential function, we could have something like 3, 6, 12. Now you'll notice that this is not increasing by the same number every time. This is adding 3 and then adding 6. But it is multiplying by 2 every time. So that's the difference here. This one, you're adding by the same amount every time, and this one, you're multiplying by the same number every time. Adding by the same number every time. And over here, you're going to be multiplying by the same number every time. Now there's certain rules for when you're increasing or decreasing for both. For a linear function to be increasing, your m has to be greater than 0. So what numbers are greater than 0? That must mean that m is positive. So for example, an increasing linear function could be y equals 3x plus 2, because that 3 is positive. To have a decreasing linear function, your m has to be less than 0, which means your m is negative. And an example of that could be y equals negative 3x plus 2. You'll notice that m is negative. We have a negative 3, so that makes it a decreasing linear function. For increasing exponential, to have an increasing exponential function, your b has to be greater than 1. That b value has to be greater than 1. So an example of that could be y equals 2 times 3 to the x. That b is a 3 and it's greater than 1. For it to be decreasing, now this may look a little funky. Your b, this means it's between 0 and 1. Well, let's think about that. What numbers are between 0 and 1? It's not 0, it's not 1. What kind of numbers are those? Those are decimals or fractions. So an example of that would be y equals 2 times 0.5 to the x. That b is a decimal, which means it is decreasing.